Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Hello students, today we will discuss about JEE Mains 2015 physics paper. Now we will discuss all the questions one by one. Okay, let us start. Students, let us solve the last question, question number 30. An LCR circuit is equivalent to a damped pendulum. An LCR circuit is equivalent to a damped pendulum. This one, LCR, because with L in the circuit and R is there. With L in the circuit, LCR, they perform oscillations like SHM, and the pendulum also perform SHM. But then what happens is, because of the air resistance, the motion of the pendulum comes to an halt. Okay. Similarly, if we think of this circuit here, the resistance dissipates the energy, and that also is like damped oscillation. Now the question is, in an LCR circuit, the capacitor is charged to Q naught. This is charged to Q naught, and then connected to L and R. So first the capacitor is charged with Q naught, then it's connected with LR circuit, as shown below. If a student plots the graphs of square of maximum charge, that is Q max square, on the capacitor with time, that means the plot of graph of Q max square versus time for two different values of L1 and L2. So here this L is L1 and L2. The two values of L are taken, given that this L1 is greater than L2. So this is a very important information, that L1 is greater than L2. So you must know that the inductor plays the role of mass. Inductor plays the role of mass, as the mass plays the role in translation motion. So inductor plays the same role as the mass in electrical circuit. So sometimes inductor is also called as electrical inertia. Now, more the mass here. Values of L1 and L2 of L, then which of the following represents the graph correctly? This graph correctly, plots are schematic and not drawn to the scale. So if I will try to solve this, then basically the question is to plot the curve of Q max square versus the time. Time is taken in this axis and this is taken in y-axis. For a damped pendulum, we know that for damped oscillation, the expression for the amplitude is A equals to A naught e raised to minus bt divided by 2m, where m is the mass of the oscillator and v is a constant. For the given circuit, what is the circuit? The circuit is one R is over here, and this is L is there, and one capacitor. This capacitor is fully charged Q naught initially, then connected with this R and L. This L is different values are L1 and L2. Now for this given circuit, we write the amplitude A equals to A naught e raised to minus R divided by 2L bracket here whatever n plays the role, the same role plays the L. L plays the role of mass. Okay, L plays the same role in electrical circuit as mass plays in translational motion. Okay, this is the inertia, translational inertia. This is the electrical inertia. Now, because what is given is that L1 is greater than L2. If I connect L1 here, which is greater than suppose L2, then if L1 is more, so if L1 is more, then energy dissipation, that means energy lost in the resistor in R will be slower, compared to when L2 is put. Okay, what is the meaning of this? So if I have two inductors L1 and L2, and if I have this is higher value, then the energy lost in the form of heat, obviously, in the resistance will be slower, because if this is higher, the energy loss will be slower. Okay, compared to when I connect L2 in the circuit. Okay, so the graph, if you see, the graph will be obviously like this. It will not be a straight line, never be a straight line, but then Q max square will be, if L1 is greater, then it will be like this, slower is this one, and here the L1 is descending fast. That means in this case this graph is not correct, this graph is correct graph, because here L1 will be, the energy dissipation is slower over here, energy so this is the correct answer, because this slope is less here. So this will be the right option. So if I plot the graph, then this L1 will be here and L2 will be below that. L1 will be here, L2 will be below that, because L1 is more, and the more one having slope, you can see, is less. Slope here is high. Okay, so this is the right answer to this question. Okay, thank you.